Today's topic is history of operating system, inside which we will see the early history. It starts from the 1940 and 1950s. Then after that 1960 to 1970 up to 1990 and above the 2000. Operating system environments, operating system components and goals, core operating system components and the operating system goals. The next is the what is an operating system. Some years ago, an operating system was defined as the software and that controls the hardware. The landscape of computer system has evolved significantly, requiring a more complicated definition. Applications are how designed to execute concurrently. In early history, the 1940s and 1950s, the operating system evolved through several phases. In 1940, early computers did not include operating system. In 1950s, executed one job at a time, included technologies to smooth job-to-job transition, single-stream batch processing system, where the punch cards are used, where the input is a punch card, then the output is also a punch card. The programs and the data submitted consecutively on tape. In 1960, still batch processing system process multiple job at once. The multiprogramming is introduced. One job could use processor while other job used peripheral devices. Advanced operating system developed to service multiple interactive users. In 1964, IBM announced a system which is 360 family of computers. Which is primarily multi-mode time-sharing system, supported batch processing, time-sharing and real-time applications, personal computing only in 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 stages. The Department of Defense developed the TCP/IP protocol, the standard communication protocol, widely used in military and university settings for the security problems. Growing volumes of information passed over communication lines. In 1980s, the client-server computing model is introduced. The client requests various services. Servers perform requested services. Software engineering field continued to evolve. Major trust by the United States state government aimed at the tighter control of Department of Defense software projects, realizing code reusability, greater degree of abstraction in programming languages, multi-thread of instructions that could be executed independently. In 1990s, the hardware performance improved, which is improved exponentially. Inexpensive processing power and storage, execute large complex programs on personal computers, economical machines for extensive database and the processing jobs, mainframes rarely necessary, shift towards the distributed computing rapidly, accelerated multiple independent computers performing common tasks. In 1990s, the open source initiative, the OSI model is introduced, founded to further benefits of open source programming, facilitate enhancement to the software products, permits anyone to test, debug and enhance the application, which increase the chance that bugs will be caught and fixed immediately. The crucial for security errors, which needs to be fixed quickly. Individuals and the corporations can modify the source, create the custom software to meet the needs of certain environment. The application basis. The IBM PC immediately developed a huge software industry, which is independent software vendor, market software packages to run under the MS-DOS operating system, which is a single user operating system. Operating system must present environment conduct to rapid and easy application of development. The application base. The combination of hardware and the operating system used to develop applications, developers and users unwilling to abandon established application base, increased financial cost and time spent. The operating system environment. Operating system intended for high-end environments. The special design requirements and hardware supports needs. A large memory space is required. Special purpose hardware is required. Large numbers of processors are required. The embedded systems. The characterized by a small set of specialized resources which is provided the functionality to devices such as cell phones and the PDA. Efficient resources management key to building the successful operating system. The operating system environments is provided by the virtual machines VMs, the software abstractions of a computer open executes on top of native operating system. The virtual machines operating system manages the resources provided by virtual machines. The applications of virtual machines allow the multiple instances of operating system to execute concurrently. The software or hardware functionality of hardware or the software not present in the system. The operating system environment. The systematic of a virtual machine block diagram is shown. The application programs which is executed on the virtual machine. The core operating system component, the user interaction with the operating system, often through the special application called a shell, and the kernel software that contains core component of an operating system. Typical operating system components include the processor scheduler, memory manager, input-output manager, the inter-process communication IPC manager, and the file system manager. The operating system architecture today's operating systems tends to be complex, provide many services, supports variety of hardware and software. Operating system architectures helps manage this complexity, organize operating system components, specify privilege with which each component can execute. Layered architecture. Layered approach to operating system tries to improve an monolithic kernel design, groups the components that perform similar functions into a layer. Each layer communicates only with each other, with each layer immediately above and below it. The processes request might pass through many layers before the completion. The system throughput can be less than monolithic kernels, and the additional method must be invoked to pass data and control. The microkernel architecture. The microkernel operating system architecture provides only small number of services which attempts to keep the kernel small and scalable. High degree of modularity, extensible, portable and scalable, increased level of intermodule communication can degrade the system performance. Network. Here is the microkernel architecture is shown. The application program generates the application programs which is executed by the operating system calls, the file system, process scheduler and the device managers. With the help of the file system and the process scheduler and the device manager, the kernel can maintain the memory management and the synchronization. The networked and distributed operating system. The network operating system runs on one computer, allows its processes to access resources on remote computers. The distributed operating system, it is a single operating system, manages the resources on more than one computer system. Goals includes transfer and performance, scalability, fault tolerance, and the consistency. The networked and distributed operating system, there are many servers. Hub can contain the nodes, and there are the many users can uh, act these nodes. They will act as a nodes which is connected to a hub, and that hub is connected to the number of servers. The microkernel architecture. The microkernel operating system architecture provides only small number of services, attempt to keep kernel small and scalable.